Okay, so this video is an update of some of the schematic wiring in the book. So let's just have a look. We've got a basic set out here, then a bit further on, past various photos, is a bit about the solar, and a bit further on still we've got a general schematic of how the grid interacts with a battery based system. However, this was written a number of years ago, and it's time, now that I'm totally happy with the system that works here, it's time to just do some basic refreshing. And I'm tidying up the wiring in the battery shed, much to the disgruntlement of several people, because they quite like the Frankenstein style wires everywhere. But there comes a point where you go, I'm just going to tidy it up a bit. I'm going to keep big industrial switches and huge amp meters, but just some of the wiring rat's nests we're going to sort out. So let's just talk about the turbine wiring to start with. We've got a rectifier, and from the turbine, which is 3-phase AC, so it's a brushless 3-phase AC generator at nominal 48 volts, you've got 3 wires, and that's the AC. So out of those 3, out of the rectifier, then you have a positive DC, and let's take it from here, a negative DC. So what we've got there, over here we have a isolating switch. Let's just draw it as a switch. And the negative goes straight to that, because it switches both the positive and the negative. On the positive side though, we then have a diode there before it goes into the switch. That's a blocking diode which allows power that way, if we just assume that power flows that way, and we don't want to get involved in that. Okay, so then on top of that we have, across these 3 phases, and how am I going to draw this? Let's just draw it like that, ignore the circuitry. Yeah, we've got a switch here which is a brake, B for brake. When you switch that on, it shorts all those 3 together. Okay, so it puts a dead short across the generator. But of course you don't apply that when it's going flat out, so I've done myself a little note here which says apply dump load first. Yeah, and then sometimes I go outside and put the brake on, or the brake's not powerful enough to stop the turbine totally, it gives more resistance, then you put that on and it stops. And once that's on, it won't start again. It might just tootle round very slowly, but it won't start. So there you go. Now then, when you come out of this isolator, the negative, that's the negative, comes down to a negative terminal, and in that negative terminal we have the solar negative. We have a wire that goes, a negative that goes off to a little fuse box, and that runs various bits and pieces, like the it's a negative for the charge controller and the trackers and the battery shed lights, etc. And then that goes to the battery negative. Okay, then we got the positive which comes out here. It actually goes through a bit of trunking to the positive. That's the negative, this is the positive. And here you've got the same thing, you've got the positive battery. So that's the battery positive. Then you've got the solar positive, and the other half of this wiring for the ancillaries. So you've also got a control which goes to the fuse box, which again is the other half of this circuit for charge controllers and battery lights, etc. So that looks like a rat's nest. You wait till you see it in the battery shed, which is where we're going to go next. So there's the battery bank, and you can probably hear it bubbling away. We've had a few days, quite a few days of grey skies and no wind, so the battery's got quite low, so they're on a sort of equalising charge now. I'm allowing the voltage to rise a bit higher than normal, and looking at the voltmeter, which has changed positions for those who've watched before, it's showing something in the region of 58 volts. Come on, focus camera. That's better. Right, and we're charging on the solar at about 15 amps, and it's sort of greyish, so that might fluctuate, and it may be that the charge controller clicks on at some point. However, this part of the video is not about this bit, it's about the turbine side. Now, I appreciate that this rectifier is a bit over the top. It's out of a MIG welder, so it'll probably handle something like 400 amps or something ridiculous. I'm just going to zoom in on one of the diodes and then show you how big they are. So they're pretty big. It doesn't even get warm on full output. Anyway, use what you've got. And that's why it looks a bit sort of untidy, because it's so huge. Okay, so that's the input from the turbine. That is the nominal 48 volts AC. So this is an output. This is the positive out from the rectifier. So that then is DC. And the DC comes down to here through the ammeter, and then it goes on to a diode. Then this yellowy sort of coloured cable is the negative, and that goes straight through to the isolating switch. So those are the two outputs that go towards the battery. Then what we've got is there are 3 black wires here, and they come off the 3-phase AC, so one off each, which then goes to this, which is a break, which is basically it shorts all those 3 wires out. You put that on and it shorts the generator out. But if you notice here, it says dump load on first, which means that you don't just apply the brake when the turbine's going flat out, you put a load on it first. And then on top of that we have a black wire and a red wire. That comes off the positive there, and the black one comes off the negative, and that goes down here and it goes to the charge controller and the turbine dump load. So although it looks like a rat's nest, there is some logic behind it. So let's move on to the next bit. Then we come over here. There we go. See if we can do that right. We don't need to see much of that switch. So there. That'll do. So this is the blocking diode, and you could go, well, there are diodes in the rectifier, but that blocking diode, again it's one of those big ones out of a MIG welder, is so that the load dump is only across the turbine and not across the batteries. So power can go that way, but it can't come back. So that's the positive, and it goes along this grey wire into the switch. And the yellow wire, I'm assuming it's yellow, but it might be green, I can't tell, goes up there, that's the negative. So let's go the other side. And then comes out the isolating switch, down here, and it goes down, that goes down to the battery. That one there is the solar negative in. This is control circuitry, but the ones we're interested in, that one comes from the turbine down to the battery. And we've also used this connection here to take power off to the inverter. And so this red wire is the positive, which comes down here to the positive terminal block. And from there, this black wire here is the positive battery. This one here is the solar positive in. That one there is the positive to the inverter. Big fat wires. You know, that's a 3 kilowatt inverter, and when it's drawing 3 kilowatts there'll be 60 amps going through that because it's 48 volts. Whereas if it's a 24 volt inverter, there'd be 120 amps, so you want an even fatter wire. Then this red wire here is the control, to control circuitry. So reasonably simple as per the drawing, and when you see it, it sort of makes sense now. But I'm starting to box everything in to sort of rationalise stuff, because when you're building you go, well, where am I going to put this? I'll put it there. And then when you start to slowly tidy up after you're happy with how everything works, then you have to move things around and keep the tails as short as possible from various items into the trunking. So just coming back to the wiring diagram, what we've added here is from here, the negative, we have a connection that goes to the inverter, and from the positive we have a connection that goes to the inverter. Big fat wires. On top of that, what we've got is on the DC side of the rectifier, which is there and there, we have a wire coming off and a wire coming off, and they go to the charge controller and eventually to the dump load, which is a resistance. So when the charge controller switches that on, that resistance, which is 25 amps, goes across the turbine, but the diode stops the batteries back feeding to this resistance, so that load is directly across the turbine and hence slows it down. Or when there's quite a lot of solar and not much wind, when the charge controller comes on, because we're up to volts with the solar, then that dump load will be across the turbine and it stops the turbine. So you just look up and go, ah, charge controller's on because the turbine stopped. Right, back to the battery shed. So just moving along this trunking here, we'll get as far as here, and then look what's there. Quite a mess. But we'll be working through that. That's all working properly, it just doesn't look very tidy, does it? So we're just going to come as far as here, and just describe what's going on there. 50 volts DC, negative and positive. Historical fitment, we'll work on that one. Then what we've got here is a little fuse board. I think it's out of a milk float actually. So we have this one here is the 12 volts from the battery. This is the slave battery, which is just down there. It's a standard 12 volt battery. I suppose we better have a look at it really. There's the slave battery. So the slave battery runs the tracking motors. We've also got 50 volts here through a fuse, and that will go off to the charge controller. Notice here I've left myself a little note to remind myself what's been going on, and this bulb here is the bulb for charging the slave battery. So one side of the bulb to negative we've got battery voltage, 48 volts nominal. The other side, because of the resistance, is 12 volts or 14 volts. So there is a video about this, can't remember what it's called, but it's about charging 48 to 12 volt backwards converter or something like that. Here it is in action. Just keeps that slave battery topped up. That's enough for the moment. We'll continue on this tour once I've got these covers back on.